Thanks everyone for making it out for our last session of the day. We have Kun and Jonathan, both technology leaders at Booz Allen, who are going to share a story about how they built a system on top of Apache Spark to support the FDA. Thanks, gentlemen.
Hey, good afternoon. There's actually a pretty good turnout for the last session of the day. Thank you all for sticking around. So I'm here with my colleague, Connie Kang. We're both part of the Strategic Innovation Group at Booz Allen, and we really focus on kind of innovative solutions for our clients, primarily federal with some commercial work weaved in. So we're here today to share with you some of our experiences helping the FDA protect the nation, utilizing Spark and AI. And so what are we going to talk about today? I did want to talk to you all about some of the work, very important work that the FDA does, how Booz Allen's open data platform helped us accelerate some of the solutioning that we came up with at the FDA, share some of the more detailed kind of journey experiences that we had around the FDA's problem, and some key findings, and we'll wrap up with that. So the FDA, the Food and Drug Administration, oversees 20% of every dollar spent by consumers. So products that they review, primarily food and drugs, but there are other products such as veterinary medicine, tobacco, medical devices, anything from life-saving heart stents to pacemakers. So over the past decade, there's really been a huge foreign production explosion of these FDA-regulated goods, and the volume has just really increased. So today, we receive imports from more than over 150 different countries, from 130,000 different importers, and they're actually manufactured at these large number of foreign facilities. So the program that we assisted on was the FDA Imports Program. And so what they're responsible for is, as these products enter our borders, whether it's actually at ports, actual physical borders, or mailing facilities, they're responsible for electronically screening all of these products. So it's a high volume of products. As of 2017, 40 billion shipments came into the country, and there's an annual increase of 5 to 10% annually. So you can imagine with the limited resources that they have, they can't possibly inspect or stop every single shipment. Not realistic. They need to really take a look at some of the features, country of origin, type of product it is, as well as certain other factors to determine whether we need to stop these shipments from getting into the country, protect the public health. And in some cases, they will also take samples of these, if it's specifically a food product, to conduct additional screening for existence of bacteria and things of that nature. So huge volumes of data, obviously a perfect use case for Spark and machine learning. Now, the program is working very well, but they can use additional capabilities to help them with some of their challenges. So, for example, there's just a lot of manual labor that's required today for them to ascertain how well their rules are working. So, again, looking at the huge volume, it's hard to determine which rules are working very well and maybe other ones that need tweaking. It takes a lot of laborious process. So that was one thing that we wanted to help them assess through the use of Spark. And kind of more long-term, what we want to be able to do is provide more robust capabilities so that they can ascertain if they change certain behaviors and how we stop certain shipments from coming into the country. What will be the effect on their workforce? Will it actually improve public safety and some of those factors? So that was kind of the problem at hand. And one of the things that we employed is Booz Allen's open data platform. We're a firm of about 24,000 technologists, developers, business analysts, and we've seen this pattern emerging over and over again for our customers. So instead of creating something from scratch from the get-go, we wanted a unified platform that would allow us to collect, process, aggregate, and expose this data in a meaningful way so that it can provide business value and insight. On top of that, we would make this data available through a single interface and allow, whether it's a visualization or further machine learning, data science kind of capabilities to be leveraged against this data set. So ODP, Open Data Platform, is an Apache license-free and open source software, and really takes the years of practice and implementation of some of these techniques and technologies across Department of Defense, civil, and commercial clients, as well as some of the internal investments. So we did want to open this up for the larger community, for us to kind of develop and build upon these capabilities. And so what's included in ODP? We've taken, and we'll take answers after our session towards the end about some of the questions you might have. And so we basically took the best of the open source technologies, built an entire framework, containerized it so that you can easily deploy it, whether it's on Amazon Web Services or in Azure. And obviously, it's not every use case will be able to be met by the ODP framework, so it provides the capabilities to swap out different technologies and also provides a data management dashboard for managing your jobs and metadata management. And then finally, there's an analytics platform. So once you've conducted your analysis on the data, we do have an analytics platform that allows you to basically capture that information and share it with the rest of your organization for easy cataloging and searching for that information. So going back to the FDA journey, so there were 3 primary steps. We obviously needed to aggregate the information and then make it available for basically the subject matter experts to utilize that information so that they can, as we talked about the prior problem of being able to assess how well their imports process is working, provide performance analytics against that. And then the phase that we're in today is the screening optimization. So how can we use machine learning and AI to predict some of the changes in some of the policy and things like that, how that would affect the workforce and how well will it work in protecting public health. So moving on, aggregation, some of the details over here. And one thing these are some of the steps that we took. So you can see down here, 3 steps. We use massive parallel jobs, the billions of records that are in these legacy systems. So we used the Spark jobs and migrate the data into a data lake. Now, all of this data isn't relevant to the specific use case we're looking at, so we filtered and joined that data set. And then we redistributed that data for performance purposes. The other thing that we realized is while we had the basic framework for ODP, which allowed us to be up and running within hours and deploy this into the client's infrastructure, there were a few things that we wanted to take advantage of. So our client's workforce right now today that's doing some of the analyses and the domain experts who are the most familiar with the data are most familiar with SQL technology. Now, you can bring in data engineers and data scientists to kind of gather this data, but these are the folks that really understand the data and know how to aggregate and combine that data together. So we wanted to provide a user interface that was very easy to use. They would not have to learn Spark, Scala, or any other type of languages. So we built this UI, and this is something that Kun's going to demonstrate and demo later on, is a platform for them to very easily using SQL aggregate this information together. And then we have a number of Spark package connectors for typical data repositories, whether it's Oracle databases. It might include something like a Solr repository, master data management systems, and things of that nature. And also allows them to output it into various different formats. So you can push it back out as a Solr index or another database, or push it into the Spark cluster. So we'll be showing a demo of that a little bit later on. So the next challenge we had was, now that we have this data, how do we actually provide it to them in a format that typical analysts or domain experts can actually utilize to figure out how well their program was working? So instead of kind of reinventing the wheel, our clients already had a TABLEAU instance stood up. So one option, after we created the TABLEAU dashboards, would have been to allow the TABLEAU server to kind of crawl through the records. But again, billions of records, it would have taken maybe a week for that to happen. So what we did was it enabled Parquet to TABLEAU TDE format. And obviously, I think a lot of you are familiar with the TABLEAU platform. We created a connector that automatically takes the data that's in our data platform and pushes it down into a format that TABLEAU can understand. So it runs on a nightly basis to provide updates and updated perspective on how well their rules are working. And so lastly, the business optimization goal. So these are some of the things that we wanted to automate as well. It's, again, a very manual process in terms of making changes to the criteria that they use to stop certain shipments from coming into the country today. So we wanted to use machine learning and basically recommend changes to these criteria, also project how the changes to these rules would affect their workforce and other organizational impacts. So I'll pause there. We do want to shift over to the demonstration of ODP. So Kun, our Chief Innovation Architect for this project, is going to run the group through that. So one of the things that Kun is going to share with you is the user interface that is available. And we actually, one of the experiments that we ran was to have one of our analysts, who was a SQL expert but didn't know anything about Spark, to actually aggregate the data together. And so utilizing this tool and his SQL knowledge and, of course, the domain knowledge about the data within, he was able to work with probably, I think it was close to 200 different tables and aggregate that information together within a couple days. So again, use of this platform to take advantage of some of the resources that you have within your organization.
Thank you. So as you can see, this is like a Spark SQL UI web interface. The reason that we built this was we've been coding for custom code for more than 2 years. And then we realized that most of the 90% of the code actually went into Spark SQL. And we have to do a lot of like ceremonial coding for starting and aggregating into moving from Oracle database or documents or file share, connecting, join them together, and then outputting into Tableau or Solr or Elasticsearch, all the stuff. So it just took like mostly 2 to 3 weeks, just get that new data ingestion get going. So we realized, what if we have a web UI that eliminate all the code and maybe all the necessary information is SQL, because SQL is like blood in the enterprise. So if we do that, then we could improve the huge productivity of the developer, not only the Spark developer, but then possibly the analyst who understands and help us out to kind of build a system ingestion engine very, very quickly. So this is one example, but we have 15 different connectors that is available. So you don't have to worry about bringing in this dependency jar in Zeppelin or notebook, and you have to bring that in. And so those ceremony you could eliminate it in one package, so that you could actually keep building and adding that new packages, and then you could just start using it right away, but still provide a UI that can be done configuration based. So that's what we built. So you just like a Oracle code in a connection, it can be configured in the UI, and then you could forget about it. So it does not have to be a developer who configures all the time. It could be the DBA that configures it, and actually developer doesn't need to know the credential at all. So you could separate the jobs roles between two. So once we have a data source configured in the central repository, then you could start using them every possible data that organization have, like Oracle database or Documentum, documents, file share, anything that you have, you separate them out as permission, and then the developers start using them right away, using only SQL. So one of the way that example is the, sorry, my mouse is, okay. So this is one of, okay. As you can see, you could define the in, which is the data connection, that you could actually choose from the already you defined by the administrator. So as you can see, you can actually select anything you want in your organization you already have available, and then you could select them from either CSV, XML, DOM, whatever it is. And then you could actually put them in the temporary table in memory, right? And then you could join them anything you want and output it into either XML dump or the memSQL or the Elasticsearch or the TABLEAU. That's the idea. So we actually had a really great success on this, and we have 3 different project team that is utilizing this without knowing any Spark or Scala code or Python. So we had a very great success with that. And then we're actually continuing on this journey. As you can say, he described that now we are moving to the machine learning, but we have this pipeline already built. So how do we actually kind of seamlessly integrate the data engineering with the machine learning, which is the Sparks did a great job. So what about we productionizing the machine learning with the SQL? If you know the SQL, you should be able to do the machine learning as well. So that was the idea that we did it, and then we actually did the 7 billion records of the imports, and we actually did the random forest algorithm on top of it, and we had a great success. We get just 5,000 record set, we get 86% of the accuracy right there. So can you imagine that we have a sentiment analysis we have to do? We have to do, I analyze the social media using these tools, and then produce the sentiment analysis on the product that FDA monitors, and then produce that report against the client. That would be a huge win, which can be done within 2 or 3 days. So that's huge improvement of the production productivity. So I'm going to present you the simple example. This is not what we do, but this is just a simple example to get this working. I mean, showing you guys within a very short time. So actually, let me run the jobs because it takes 3 minutes. So let me just go ahead and run it.
Yeah, and we were not able to share FDA's data with you all today, so for this demonstration, we pulled some publicly available information about cancer patterns, shape, size, thickness, and Khan's going to share with you the kind of the use case that he's going to run through.
So while they're running, so I will show you how we actually do the machine learning using SQL only. So we utilize the breast cancer example. So we just read it from the CSV. So of course, you don't have to do any ceremonial access for that. And you just define that configuration. You read the cancer training set like this, and then select from the cancer set from the CSV. And then, if you're familiar with the data machine learning, you have to actually change the data set to a number or number vector array integer number. So this is one example that you heavily do. So we actually provide the user-defined function. You can change the number to prepare your data set for the machine learning. And then finally, you could use the user-defined function that we already provided with the SQL statement. You could build your model. So in this case, train binary classification class. Class is where that, yes, this is cancel, or yes, no, this is not a cancel. And then we provide the features, which is the column of the data table, with the thickness, size, shape, and so on and so on. So this is, if you run this, actually, it's going to build the model for you and save it into the certain location where you already configured already in the data source. So let me go back to main page. So as you can see, it's already done. So this way, you don't have to know anything about machine learning at this point. Maybe it's stretch, but if you know what you're doing, this actually will help you out, like that, speed it up your machine learning model building. So can you imagine that you could actually use the XG boosting without ceremonial code? That's huge, like speed it up, so that you could try out different machine algorithm to see if what data set tell you what pattern that you could find it from. And then finally, you could do the testing and evaluation of that using running this. So here, again, we get the data set from the untested data set, and then which is CSV again. You could grab it from the database if you want to, and then change the data. Again, finally, you do actually prediction. So now, hey, do the binary classification that we already created a model. And that will, so as you can see, there's no class column which will tell you yes or no prediction there are the answer. So we don't have that, and then this user defined function will actually tell you yes, no answer predicting. So once you got that prediction, which is we'll save it into the prediction table, which is here. The prediction table will have all the result. Yes, the prediction of yes or no, this is a breast cancer or not. And then you actually compare those, the result from the real data set, yes, it was cancer or not. You grab that from the CSV again to see whether the prediction was accurate or not. And again, to validate that, you don't have to go through this special package that Spark provides. You could just use a simple select statement whether there was a right or wrong answer by doing, so pre-join them, and see if like one that is right and one that has predicted, join them with a select statement again. And then you could do the correctness of the count. So you could actually see how many gets corrected by comparing the result prediction and the right answer actually from the real answer from it. So you could actually see how effective it was, the prediction model it was. So this actually helped us to try out different data set, data engineering problem, and then we could also solve try out different model very quickly. So one of our ex-Booz guy was like using this in their production, and they loved so much that they asked us to see if they could use this product. So we've been thinking to using the ODP to share this knowledge and the packages, and I think this is kind of working very well for us. So hopefully you guys can take advantage of this product.
Okay, thank you, Kun. So we'll actually share a link here. Give us 1 second. Yeah, so we do have a GitHub repository, and some of these are new capabilities that Kun was describing. So we did want to share the GitHub link and also share contact information. So if you have further questions about the Open Data Platform or this specific variation of it, or the FDA in general, please feel free to reach out to us. And going back to some of the key lessons learned, I think especially in a regulatory setting, you can automate a lot of things, but there will always be a human factor in terms of having that belly button for somebody who is ultimately responsible for making those decisions on those policies about these imports. So that was one of the things that we learned. And The other thing is obviously one of the things that really is impressive about Spark is that you're able to experiment and try things out very quickly. And if you look back at some of the traditional way of bringing kind of business insights and value, people would build data houses, create ETL processes. It would take months for you to get any insight. And I think really this technology is innovative in the fact that you can really try out new things and show value to your clients very quickly. So with that, I think we're done with the presentation, and we'll leave. I think we have 5 minutes for questions if there's any.
Any questions?
I think everyone's eager to get to dinner, maybe.
Everybody ready for a drink? Okay. Thank you very much for your
Okay,
presentation.
all right, thank you.